Hello and welcome to my home tuition's YouTube channel. In this video, I'm going to discuss finding the arc length, area of sector, and area of segment in a circle with the help of Casio fx-570EX class width calculator. This video is sponsored by Casio Malaysia. Pi and radian. Pi is a mathematical constant representing the ratio of a circle's circumference to its diameter. It is approximately equal to 3.14159. For example, let's say the circumference of this circle is equal to c and the diameter is d. Pi is equal to the ratio of c to d, or c over d. The diameter d is equal to 2 times of the radius. It can be written as 2r. Therefore, the circumference c is equal to 2 pi r. A radian is a unit of measurement for angles, where 1 radian is equal to the angle subtended at the center of a circle by an arc equal in length to the radius of the circle. For example, let's say we have a circle with radius r. There is an arc on the circle, and let's say the arc length is s. This arc makes an angle theta at the center of the circle. By the definitions of radian, the angle theta is equal to s over r. So this is how the angle in radian is defined. In previous slide, we learned that the angle subtended at the center of a circle by an arc is given by the equation theta equal to s over r. We can rewrite this equation as s equal to r theta. This is the formula that we can use to find the arc length. Take note that theta is the angle in radians subtended by the arc, and r is the radius of the circle. Let's see this example. Let's say we have a circle with an arc. The arc subtended an angle of 45 degrees at the center of the circle. To calculate the arc length, we use the formula s equal to r theta. In this case, r equal to 12. Remember, to use this formula, the theta must be in radian. Therefore, we need to convert 45 degrees to radian. It is equal to 45 degrees over 100 degrees times pi, which is equals to 1 over 4 pi. Now we can substitute this angle into the formula. We get s equal to 3 pi. Converting the units of angle by using the calculators. Often in circular measure, we need to convert the unit of angle from degree to radian and vice versa. We can perform the conversions easily by using the Casio calculators. Let's say we would like to convert 45 degrees to radian, and let's bring in the calculators. If we would like to convert an angle to radian, we need to set the angles to radians. So let's go to the setup, okay, and then choose angle unit and choose radian. Okay, and after we set our angles to radians, then we key in, or we input the 45 degree. To input 45 degree, we key in 45 and then go to options, and here we can see angle units again. So we select 2, and then they ask us what's the units of the angles that we would like to input. And here we would like to input degrees, so we choose 1 and then equal. And then we can see that here the display shows that the angle is 45 degrees, and we already set our angle to radian. So if we press the equal key, it will convert 45 degrees to radians, and this is the answer. Therefore, 45 degrees is equal to 1 over 4 pi radian. So let's write our answer here. 45 degrees equal to 1 over 4 pi radians. Now, if we would like to convert radian to degree, then we need to set our calculators to degree. Let's bring in the calculators again. Now, this time, let's go to setup and then change the angle to degree, because we would like to convert our answer to degree. And then let's key in radians. So 2, and then go to options, angle units. Now, this time we choose 2. 2 is radian. So 2 radian. Here it shows that the readings of the angle is 2r. R stands for radian. And then we are going to convert this radian to degree. So when we press equal, then it will convert 2 radian to degree. And the answer is 114.59 degree. Let's round up to 0.6. So therefore, 2 radian is equal to 140.6 degree. That's how we convert degree to radian and radian to degree by using Casio fx-570EX class width calculator. Let's say we have a circle. The angle at the center of the circle is equal to 2 pi. There is a sector in the circle. The angle of the sector at the center of the circle is equal to theta. The area of a sector is equal to the fractions of the angle subtended by the sector of the angle of the circle, and then multiply to the area of the circle. The area of the circle can be written as pi r square. Cancel off the pi, the area of the sector equal to 1/2 theta r square. Now let's see this question. This is past exam questions 2016 paper 1 question 19. The diagram 19 shows a circle with center O and radius 8 cm. Given the length of the minor arc AB is 16 cm and use pi equals to 3.142, A, state the values of theta in radians, and B, find the area of the major sector OAB in centimeter square, correct to 4 significant figure. Let's start with question A. In question A, we are asked to find the values of theta in radian. By definitions, the theta or the angle in radian is equal to the ratio of the arc length to the radius of the circle. And in this case, the arc length is equal to 16 cm and the radius is equal to 8. So therefore, this is equal to 2 radian. Okay, B. Find the area of the major sector OAB in centimeter square. Okay, the small one is called the minor sector and the big one is called the major sector. In order to find the area of the major sector, we need to know angles in the major sector. Now, the angle in the minor sector is equal to 2 radian. So the area in the major sector is equal to 2 pi minus 2 radian. Because the angle of a circle is 2 pi, and then minus the angle in the minor sector. The area of a sector is given by the formula A equal to half r square theta, and this is equal to half times 8 square because the radius is 8, and the theta is 2 pi minus 2. Okay, and let's use our calculators to find the answer. Okay, so in our calculators, we key in the fractions 1/2, 1/2, and then times 8 square, and then times bracket 2 pi minus 2. So 2 pi and then minus 2, and then close brackets. So the answer is 137.1 centimeter square. If we draw a chord in a circle, the region enclosed by the chord and the arc of the circle is called the segment. The small one is called the minor segment, and the big one is called the major segment. A segment is part of a sector. Let's say the radius of the circle is r, and the angle of the sector is theta. Let's split the sector into the segment and the triangle. We just learned that the area of a sector is equal to 1/2 r squared theta. You should also learn that the area of the triangle is equal to 1/2 r squared sine theta. Therefore, the area of the segment is equal to the area of the sector minus the area of the triangle, which is equal to half r squared theta minus half r squared sine theta. This is the formulas that we are going to use to find the area of segment. Let's see this question. This is past exam question 2016, paper 2, question 7. Diagram 7 shows a sector BAC with center A and sector AOB with center O. It is given that OA equal to 17 cm and AB equal to 8.8 cm. Use pi equal to 3.142. Find A, the angle OAB in radians, B, the perimeters in cm of sector BAC, and C, the area in centimeter square of the shaded region. Let's start with question A. Question A, we are asked to find the angle OAB. OAB is this angle, and take note that this is an isosceles triangle because these two sides of the triangle is the radius of a circle, and the radius of a circle must always be the same. So this is an isosceles triangle, and therefore these two angles must be equal. So to find these two angles, we take the angle of a triangle, which is pi, and then minus this 30 degree. Okay, we need to convert it to radian first, and then we divide it by 2. So let's start. So question A, let's convert this 30 degree to radian first. So 30 degree is equal to 30 over 180 times pi, which is equal to pi over 6. X is equal to pi minus pi over 6. Pi is 180 minus pi over 6, and then divided by 2 because we have 2x here. And this is equal to 5 pi over 6 and then divided by 2, which is equal to 5 pi over 12. Okay, so this is angles OAB. So OAB is equal to 5 over 12 pi radian. Okay, and we can use calculators to find the answer in decimal numbers. Okay, so 5 over 12 and then times pi. Okay, this is equal to 1.309, equal to 1.309 radian. Okay, now B, we are asked to find the perimeter in cm of sector BAC. So BAC is this sector, and to find the perimeters, we know that the radius is 8.8, and we need to know the arc length. To find the perimeter, we need to know the arc length, and then we just learned that arc length is equals to r theta. Okay, and r is equal to 8.8, and theta we just learned that is equal to 5 pi over 12, or 1.309. Let's use 1.309, and this is equal to 8.8 times 1.309, so equal to 11.52 centimeters, and therefore the perimeter is equal to 8.8 times 2 and then plus 11.52 equal to 8.8 times 2 plus 11.52. Okay, this is equal to 29.12 cm. C, we are asked to find the area in centimeter square of the shaded region. Okay, now the shaded regions consists of the sector and a segment. Okay, so let's find the area of the sector first. So C, so area of sector ABC. Okay, so area of a sector equals to half r squared theta. Okay, in our case, r is equal to 8.8 square, and theta, and just now in A, we already find the angles OAB, which is equal to 5 pi over 12, right? So this is equal to 5 pi over 12, which is equal to 1 over 2, and then times 8.8 square, and then times 5 pi over 12. Okay, so this is equal to 50.68 centimeter square. Now let's find the area of this segment. The area of this segment is equal to the area of the sector and then minus the area of the triangle. So area of segment equal to area of sector equal to half r squared theta, and area of triangle equal to half r squared sine theta. Now this time, let us use the calculate functions in the calculators to perform the calculations. Let's key in these expressions into the calculators. 1 over 2, 1 over 2, and then the r squared. Now we don't have the r letter here, so let's say we use b for our radius. So alpha b, and then square, and then the theta. Let's use x for theta. You can use any letter listed here, A, B, C, D, E, F, and X, Y. Okay, so I choose X. And then minus 1 over 2, 1 over 2, and then R is B, yeah, the radius is B, and then square, and then sine theta. Theta is X. Now take note that I already set my angles to radian, because this theta is in radian. Okay, so after I key in the expressions, then I press calculate, and so the calculator asks us what is my values of b. B is the radius, and just now we learned that the radius is equal to 17, so 17. Then they ask us what's the values of x. X is the theta, and just now we already found that x equal to pi over 6. So x equal to pi. So shift pi and then over 6, and then equal, and press one more time, equal again. Okay, so this is the answer, 3.41. 3.41. So the area of segment equal to half 17 square, and then pi over 6, and then minus half 17 square sine pi over 6, and equal to 3.41 centimeter square. So therefore the area of the shaded regions, area of shaded region equal to 50.68 plus 3.41, which is equal to 54.09 centimeter square.